For the next several minutes, let's take an in-depth look at the ArraySum program in the text. As with every other program that we've written, it starts off with main. What makes it different, though, is that main is going to call another procedure. When you think about it, that's pretty much just what we would do in a high-level language. The other procedure is named ArraySum, and we can see its code down here. There's a comment above the ArraySum procedure, and let's take a look at what it's showing us. First of all, the name of the procedure, what it does, what the module receives in terms of parameters. We're going to talk more about parameters, though, later. And then it's explaining what it returns and how it returns it. So part of our class format for writing programs with procedures is to put a comment like this one above each procedure. It's part of good documentation practice and a good habit to get into. Maybe the textbook explains using procedures fairly well, but I want you to see how using procedures affects memory, especially memory in the stack. We're also going to be looking at some more advanced ways to use the debugger. With that said, let's start the debugger. First of all, notice that the register window is already open. But what we haven't done before is to dock that register window someplace else on the screen. So just grab it and pull it down someplace out of the way. Notice you can resize it and you can move it around. I'm going to go back and do the same kind of thing with a memory window. First, I need to make this section of memory point to our data segment. Next, I want to make these appear as 4-byte integers. And you can see the values in there, the 10, the 20, the 30, and so on. Now I'm going to drag that window where I want it and resize it. I can tell how many columns I want showing. And we'll just put this one up here for now. Here's something new. I'm going to get a second memory window. So I go up and I pick the window 2 choice and drag it down and resize it like we did the others. I'll set this to 4-byte integers also and do a little bit of resizing here and there. The main idea is just to get these where they're convenient and out of the way of your code. Now I want to point memory 2 to the stack, and I do that by just putting the ESP register in the address bar because I know ESP is pointing to the stack. Please see 2 things. Number 1, look at the address of the stack. That's where the ESP register is pointing. Number 2, notice the contents there. That number doesn't mean anything to us, and it shouldn't. As we begin stepping through the code, we'll move the offset of the array into the ESI register and watch ESI change. Also, see that the instruction pointer changed. That means it now contains the address of the next instruction that will be executed. And let's not forget to make the memory displays automatically update. I'm going to do that with both memories that we're showing on the screen. Now we'll get the array length into the ECX register. Take a look at it. It holds 5, which is how many double words are in the array. Look at the instruction pointer. Again, it's pointing to the next instruction's address in the code segment. At this point, we're ready to call the procedure named ArraySum. Now normally I just press the F10 key to step through the program. But if I do that here, it would just run the ArraySum procedure and come back to the next line of code in main. We wouldn't get to see what the procedure really does. If you go up to the debug choice on the main menu, look at what F10 does. It's called step over. Then look at what F11 does. It's called step into. And we can go to the little icons on the taskbar, and you could click those, and they do the same thing as the F10 or F11 keys. Before we step into the ArraySum procedure, look at what the instruction pointer contains. You might even want to jot that down, 000110026, and that's in hex. Remember, that's the address of the next instruction, which is the procedure call on line 18. Look at the debugger's little yellow arrow. Now we'll press F11 and enter the new procedure. Check out what happened in memory. The stack has a new value at the top of it. Look at the address. It's different from what it was earlier. The old value that ESP pointed to looks like it's moved to the right. But really what happened is the ESP register is pointing 4 bytes lower in the stack. You got to remember, the stack builds downward, even though we might think of it as a stack of plates building upward. Look where the ESP register, that is the top of the stack, is pointing. Remember, that's the address of the next instruction on line 19 in main. It's pushed on the stack so that the CPU will know where to go back to when this procedure is done. The next thing will be to push the ESI and the ECX registers because we'll be using them in the procedure. Before we do, look where ESP is pointing and look what's on the top of the stack. So we push the ESI register, and it appears that the ESP register has changed, and what is contained in the ESI is now on the top of the stack. Then we'll do something similar with the ECX register. It contains 5. Now the value 5 is at the top of the stack, and look where ESP is pointing. Look at the address that the stack is showing. We're letting the EAX register contain the total, so we've got to start it to 0 at the beginning of the procedure. Then we begin the loop. The ESI register points to the first double word in the array, so we add it to EAX. Then we point ESI to the next double word in the array and go back to the top of the loop. ESI now points to the 20, so we'll add it to the total in EAX. Update ESI again and go back to the top of the loop. Pay attention to the changes in ECX, EAX, and ESI as we step through the loop. Finally, ECX contains 1, so we know we're on the last iteration of the loop. ECX goes to 0, and so the loop stops. EAX now contains 96 hex. The instruction pointer contains the address of the next instruction on line 38. Look where the debugger's yellow arrow is. Look at the 5 at the top of the stack. Look at ESP, and look at ECX. They're all going to change when the pop instruction executes. Now look at them again. ECX has its pre-procedure value of 5, and ESP points to this value at the top of the stack because the 5 was popped. In similar fashion, the current top of stack is popped into the ESI register. So ESI gets its pre-procedure value back. And the value at the top of the stack is the address of the next instruction in main on line 19. Be sure you see that we didn't save the EAX register's contents at the start of the procedure, because we knew we'd be returning the total in that register. Now the instruction pointer points to the last instruction in ArraySum, which is the return instruction. When it executes, watch the value at the top of the stack get popped into the instruction pointer. And then we'll be ready to execute the instruction on line 19 in main. Now ESP points to where it did before anything was pushed onto the stack, and the instruction pointer points to the code on line 19. Again, look at the little yellow arrow. All it's left to do now is to copy EAX, which contains the total, into the sum variable. And here's where that variable is in memory. It's right after the array. And the program ends. I'm hoping a combination of reading the text and going through this video a time or two will let you see how procedures work and the basics of how the stack is used for return addresses and saving registers. We're going to go into more detail later, but this will get us off to a good start. If you have any questions, please let me know. And thanks for watching.